Hey, good morning, and thanks for all the hard work over the weekend, getting that test done and getting chapter one. We are going to start with chapter two. Chapter two is really, you're going to find at the end of the week, we're going to do the exact same problems that we did before, but we're going to kind of present them in a new way using logic and here we go. So I will start you with what is the car's parking spot number. You can look at this for a second. Then, if you've seen this before, maybe you take this and you swap it around and it becomes a little bit more obvious. The point of this little start is I'm going to present some stuff. You need to kind of look at it in different ways and appreciate different people's opinion on logic because it can come in many different forms. Here we go. Where am I going to do this? Oh man, any kind of job that requires you to go through a process. We've all had a boss in our life that yells at us and tells us to do something without justification. Sometimes maybe you feel like a teacher gives you something without justification, and that is our fault, and you should ask for justification. In mathematics, we get blamed for this a lot. We don't tell you the connections to calculus that you're learning. This could be the most important part of mathematics that you learn because of where you're going in your life. Many people don't use numbers every day, but they use the thought process and they have to make decisions, and how you justify those decisions really help your life. So here's a software engineer. They do it every day. We're not all going to be software engineers. Here's a lawyer. The lawyer is, I think, a better kind of illustration of what you will do. And sure, you in a court of law, you have to prove something. Well, not just in a court of law. Every day, if you're hanging out with your buddies in the backyard of the barbecue, you can't just yell out, "This is the way it is." But if you have a sound argument and you lead people through it, then you kind of have great discussions and everybody gets better. So when people find counter examples to yours, sometimes that illustrates to you maybe your thinking is a little off. So it's a nice way when everybody's playing by the same rules. All right, today, if I were the happiest person in the world, you would walk out of here with some skills like being able to understand what a conditional statement is, be able to write them, and their converses. Those are the biggies. And basically, those are if-then statements. If this is true, then this is true. So we live our life like that all along. If I give you homework, then I should do it. If I'm hungry, then I should eat. So that's kind of how we run our life. Well, same thing in proving a point. Biconditional is just a really fancy way of shortcut. So we'll talk about that. If you were to understand the difference between inductive and deductive reasoning, it's something that's come up in science classes a lot. It happens in math all the time. Inductive is something, hey, and this is what we do most of the time in our life. We see something and we go, oh, and we see it again and again and again. We make a decision. Deductive reasoning is not only do we think we know, now we go in and use tools to prove it. So it is or isn't going to be true. Conjectures are really good guesses. All right. Conditional statement is an if, then statement. That's it. Now, sure, we might mix that up and not use the word if or though were then exactly. But if you have kind of two things, one leads to the other, it's we can call that a conditional statement. So if you go to Pooter, then you were given a laptop. Very good. You know, oh, but my buddy, he lives down here, he didn't get there. Yeah, there's going to be counter examples and some things that don't quite work. Whoa. All right. We have two parts of an if-then statement. The first one is called the hypothesis. The first one is called the hypothesis. And the second is called the conclusion. You can almost guess which part is the hypothesis and which part is the conclusion, but I will go ahead and make that clear. After the if part is always the hypothesis. Notice I don't say the first section is always the hypothesis. I say the hypothesis goes with the if. The then part is called the conclusion. In tonight's homework, they're going to say identify the conclusion, identify the hypothesis. The conclusion is always with the then part. Yep, that easy. In the following example, circle the hypothesis and underline the conclusion. All right, so let's go through and do the hypothesis. So I see an if, so I will say yesterday was Wednesday. And some of these are like puzzly-ish. You know, it's kind of like to make you think about it and which way and stuff like that. Oh, here's the if part. If you go to Pooter High School. And in this case, the if part is in the beginning. If the measure of angle B is 90 degrees. Cool. Well, that was pretty darn easy. Now the conclusion, I look for the then, and I see it right here. Then today is Thursday. So today is Thursday is the conclusion. I see the then, so the mascot is Impala. And finally, I see the then, so that means this is an angle. Hey, what's cool about if-then statements is also you can now read them and just say, are they true or false? Very important. If they're true, they're always true. If they're considered false, they might be true sometimes, but other times they don't work. If there's one situation that makes the if-then situation false, then it is considered a false statement. So if yesterday was Wednesday, then today is Thursday. That's basically true. There's no way around it. If yesterday was Wednesday, if that was true, then today is Thursday. That's definitely true. If you go to Pooter High School, then your mascot is an Impala. Yeah, we could say that's true. Are we thinking like, no, you know, in my heart and soul, I don't know, I can't think of too many other things right now. You might have another mascot, but basically, if you're thinking about the mascots, yeah. And if 90 degrees, then we know that angle B is the right angle. If it's 90, then that is absolutely true. So I can't think of any counterexamples. So we'll move on. All right. So you're given plenty of conditionals. Great. If angle B is 90, then it's the right angle. That's kind of a math geometry thing. We might be very interested in flipping that if then. So if I'm giving you a conditional, then the converse. And so tonight I'm going to ask you, given this conditional, write the converse. So what do? You just switch the P and the Q. Mr. Sayers, what is the P and what is the Q? You kind of skipped over that. So I really didn't skip over that. Let's just address it right now. I don't want to write the statements every time. So kind of P stands for this like little statement of words. Okay, and then Q is also a statement. And instead of writing the if-then statement every time, we're just going to say in general, if P, then Q. You get to pick the P, you get to pick the Q. All right, so when we write a converse, we just switch the hypothesis and conclusion. That's it. So it's like, still not following you, Sayers. Let's do an example. So if two lines intersect to form a right angle, then the lines are parallel. That's great. So we have a hypothesis and we have a conclusion. Okay, to write a converse, we start out with if. Now what we do is we switch. So then we take if the lines are perpendicular, then maybe come on. Almost fits. Let's see if I can squeeze that over. I don't know what that if is for. Let's float that up here. Okay, so basically the converse is just rearrange the statements and you're good to go. If the lines are perpendicular, then the two lines intersect to form a right angle. Very good. Easy peasy. Whoa, that's a lot to look at. Let's just look at one or two. Write the converse of each statement and determine if it is true. So to write a converse, you have to identify the hypothesis and identify the conclusion. So here is the hypothesis, and here is the conclusion. So if I'm going to write this as a converse, all I'm going to do is switch those two. So if you win, then you score more runs. So do you see they just, here is, here's that part, and then here's that part. Why is that important, Sayers? Why are we doing this? Because when we make rules up in mathematics, if you have vertical angles, then they are equal measure. Can we rewrite it as if they're equal measure, then they're vertical angles? And sometimes yes, and sometimes no. It's an important aspect of mathematics. All right, at this stage, maybe you're picking this up. Maybe we go down to C. Let's look at C. All right, if you go to Poudre High School, then you go to school in Fort Collins. Yeah, that makes sense. That's obvious. So if we switch those two, then it's if you go to school in Fort Collins, then you go to Poudre High School. So do you see how we just switched the two statements? No big deal. Now, the question is true or false? True or false? This one is true. If I go to Poudre High School, I'm definitely going to school in Fort Collins. Absolutely. But if you go to school in Fort Collins, then do you go to Poudre High School? Maybe. Maybe you do. Maybe. But what other unfortunate schools could you go to? Yep, Rocky Mountain High School is one of them. So that is one situation that satisfies this but makes this false. So we give that a false. All right. Let's just have some fun with D. If you're from Colorado, then you are a Broncos fan. That absolutely should be true, but I know many, many of my friends are not Broncos fans, and some of you are not Broncos fans. And guess what? It doesn't matter in the big scheme of things. Sports are kind of fun, but I am not at all going to freak out. So that is false, unfortunately, for me. You know, I like the Broncos. If we go down here, if you're a Broncos fan, then you are from Colorado. Well, that is also false because there are many people. Most sound people in the United States are Broncos fans, but you know, I can only say that for. And I'm joking, of course. All right. Well, I want you to have some fun with those. And all you're doing is trying to find one example that doesn't make it work. hey, biconditionals, if the conditional and the converses are, make sure you have this in your notes, both true, then you can write what we call a biconditional. A biconditional. Oops, sorry. So in general, that means we have if P, then Q. So we have a conditional. If we do the converse, then we're switching those. So if Q, then P. That's a lot of work. You know, I'm okay. I'm pretty tough. And we say, hey, that's a true statement and that's a true statement. If that's true, then we can rewrite this and write both statements at the same time. Why write both? If they're both true, why switch them? And yeah, great. They can be written as a biconditional, and that's written P if and only if Q. So sure, it's like, whoa, it's no longer a conditional statement, but it has this little magical statement that means this is true and this is true. So the rule is, if you have a conditional and you write its converse and you decide that they are both true, then it can be written as a biconditional statement. And how do you write a biconditional statement? You do the first statement, you put in the if and only if, and then you write the second statement. Oh, Mr. Sayers, could I switch those two? Absolutely. Okay, these can be switched. There's no order. That doesn't have to be, since these can be switched and they're basically converses of each other, it could be Q if and only P. Cool. All right, there are two other things that you can do to a conditional, but we find that they're not that valuable in this book or later, but I'll tell you where it is valuable if you're into logic puzzles. So, and you're like, no, but yes, you are. I know you are, because they're just interesting, and I'll show you some this week. Lewis Carroll, famous for Alice in Wonderland, used to write these little 4-line puzzles, and you had to use this logic to like unravel them to come out with a secret message. Really fun. So I'm just going to cover what an inverse is and cover what a contrapositive. All right. So to write an inverse, you start with your conditional, if P, then Q. And an inverse is if not P, then not Q. What the heck? What does that mean? It means opposite. You know, it's kind of like that annoying teacher that you say, hey, this is too much, and then they say something like, it's too little. Or, hey, this is too much weight on this bar, and somebody says, that's not enough weight. You know, it's just that opposite statement. It's hot, it's cold. All right, so let me walk you through one example. Let's identify the hypotenuse, and let's identify the conclusion. So what we're going to do is write the opposite, all right? And the word not is used quite a bit in this. So if yesterday was not Wednesday, then today is not Thursday. That's it. Don't overthink it. Just make it the opposite of that statement. Make it the opposite of that statement. Hey, the contrapositive. This is like, ooh, fancy. So now you're getting paid a lot of money. If you're given if P, then Q. What's cool about the contrapositive is you get to switch them or negate both statements and switch places. So here you're going to say if not Q, then not P. So you're going to take this statement, you're going to negate it, and it's going to go over here. Oh, no way. And on this one, you're going to negate it, and it's going to go over here. So contrapositive does as much as you possibly could to a conditional. So let's try it. So here we go. If it's raining, then I'm not happy. All right. So some people like to do the converse first. I'm not going to because I think I can do this in one step. So in one step, I'm going to start out with if. Then I'm going to do the opposite of the I'm not happy. The opposite is I'm happy. Then the opposite of it's raining is it's not raining. That's it. I know, it's like, now, Mr. Sayers, I can honestly say, don't think I'll ever use that. This is sort of a fun little toy tool in mathematics. Yes, you can always look at it on your shelf and go, God, that's that contrapositive thing. And maybe you don't use it, but some of you might go into philosophy or debate or law, and all of a sudden, these are the tricks of logic that can put together what we call an argument. An argument doesn't have to be this heated yelling match. An argument is a good, sound, logical way of putting your thoughts together to get from A to B. All right, so that's why I cover it. I don't want you to not know that that exists, but there you go. So there's our summary. If you start out with a conditional, there's a few things you can do to it. That is our favorite, converse. We will definitely use the biconditional, and this is definitely a lot more for fun than what we'll use in this class. But my favorite is the contrapositive. Oh man, I'll show you something about Lewis Carroll the next day. All right, we are going to skip that because this is long enough. And I will get to this at some point. There's some fun things. I just want to get to the homework. There we go. So this is a really short homework. I got to tell you that I'm not going to be too available this week. I've got some things going on in my life that you know are really demanding time-wise, and I'm sure you guys have the same thing. So we need to work with each other this week. If you have these questions, I'll certainly try to get to them. Your best way of doing that this week is to email me and say, hey, Mr. Sayers, can you give me write-up number 22? You know, and I'd be happy to do that. So give these a shot. Wish you the best of luck, and we'll talk to you soon.